Shake Table by Gabbie, Doty, and DeGiorgio. Before we created the tower, Gabbie and I needed to figure out the dynamics of the building. We suggested different heights for each floor and the possible width of the building. In the end, each floor was 18 centimeters high and the base of the building was 18 centimeters wide. Making the base was very important in order to make the building turn out well. We connected 4 straws into a square to make this base. Before we started building the floors, we had to create bolts through the cardboard to make sure the building did not fall when we shook it on the shake table. When we made the structure of the tower, beams, floors, etc., we connected 2 straws together to make one long beam. We then taped 2 beams together to provide our tower with a sturdier structure. To make sure our tower didn't lean, we crossed 2 straws in each of the faces that were created when we made the square floors. The triangles made by the crosses make the building more sturdy than any square would. We did this for every face for each square floor. Overall, our tower turned out to be almost exactly like our original drawing, though the total height turned out to be different since the architect wanted us to make a roof. We used colorful paper and designs to make our tower stand out. In the end, our tower is 86.36 centimeters tall. Our base was 19.5 centimeters wide, and the beams leading to the beginning of the first floor were 19 centimeters. The first floor was 21 centimeters wide and 18 centimeters tall. Finally, the second floor was 20 centimeters wide and 10 centimeters tall. Because the architect wanted us to design a roof, our building became a lot higher than 36 centimeters. Before we placed our tower on the shake table, we did a static testing to see how stable our building was. We placed 2 sandbags on each floor, each sandbag weighing 250 grams. Our building was pretty stable. To strengthen our building, we used lots of tape to secure where 2 straws met. We made the floor of each room 4 straws that crossed in the middle. The crossing straws along the walls of the tower also made it stronger, as well as the bolts that made our tower stay bolted into the cardboard. The strongest part of our tower is the support for each of the floors. We crossed 4 straws into the center, so the center of the floor is the strongest part of the flooring because the straws crossed in that area. Our weakest part of our building is probably the cross sections along the walls. They cause the tower to lean a little bit, which will probably cause it to fall quicker. Hopefully, the tape we placed will be able to help with that. A lot of tape was used in this project. To seal the connection between the 2 straws we used to make one tall beam, we wrapped tape around the area that was connected. We also did this for the corners where multiple straws met, in order to provide the building with more stability. The extra supplies we used were paper and Legos. With paper, we decorated the roof and floors, but the floor paper was also used to create a stronger platform for the sandbags. We also used a Lego man to add some creativity to our building. This is our tower's second experience with a major earthquake. On each floor, there are 4 sandbags, making a total of 8 different sandbags.
Take a video. Oh my god, there he goes. He looks stylish.
He's just flexing to show his muscles. Our tower collapsed from the weight of 6 different sandbags on each floor.
Oh, come on, you can do it. You can do it. You can do it. No!
Of course, our building moved a lot during the earthquakes. This graph shows how strong the different movements were. The blue lines, z-axis, shows how strong the force was each time the building bounced. The orange lines, y-axis, shows how much our building moved back and forth. And the green lines, x-axis, shows how strong the force was each time it moved side to side. Our building seemed to have bounced a lot. Our building was able to support 10 sandbags, each weighing 250 grams. Our building failed at the bottom, where the straws weren't strongly connected and they were unable to hold the extra weight added by the sandbags. If I could change anything about our tower, I would make the bottom a lot stronger so it would be able to hold the extra weight. I would probably make stronger cross beams to be able to hold it. I learned that in order to have a building that could hold the extra weight added by the sandbags and the shaking of the earthquake, you need to make a very strong bottom to be able to support the extra weight. I enjoyed this lab because I was able to have fun and learn about the different styles of buildings and learn how to make an earthquake-proof building.
Our building was able to support 10 sandbags. Our building failed in the cross beams in the front right here because they're not able to support the weight. If I could have changed anything about our building, it would have been to add a support beam through the center of our building so it could support all the floors. I enjoyed being able to channel my inner creativity by building a roof of my own, and I also very much enjoyed the process of building it.